Good evening, all of you, and welcome to this part session. In today's part session, we are going to talk about information management systems at KGFS. So here in this session, we are going to cover how we manage all the information at the KGFS, from when the data is collected to how we build an integrated information management system. So let's quickly take a tour of different systems through which data is captured at KGFS. First thing is KGFS customer management system. So in this system, all the customer enrollment information and details about the customer's household income, expenditure, as well as liabilities, and all this information is captured. Also, third-party product sale like insurance products, NPS, and other PC products are and there is core banking system. So this is essentially a loan management system through which the loans that are originated from KGFS are disbursed to the customers, and subsequently all the repayments and transactions are due through the system. We have a geographic information system which collects geospatial information of the customer. So this in turn loops back into the customer management system which connects to the customer database. Then we have a central audit system which is primarily important for the audit functionality of the KGFS. This has the branch level audit information and branch audit. Then we have a learning management system through which all the wealth managers are administered certain tests and certifications are administered through the system. All the content that they need to update themselves with on a regular basis, and especially the knowledge sharing primarily happens through the system. And we have the HR management system. So this is the HR system of the KGFS wealth managers. So all their joining details and their association with the KGFS is managed through the system. So here we are talking about 6 different systems, and maybe if we look at why we really need these 6 different systems in spite of just having one integrated system. So the essential need for having 6 different systems is each of these systems we see is specially designed to achieve a specific functionality. As in the customer management system in depth deals with all the customer relations and the day-to-day information of the customer. So is the case with all these different systems. So each of them have evolved at different points of time based on their requirements. And each of these systems is very unique in its own functionality that it is interconnected. So that is the reason why we have 6 different systems through which all the data is captured. So next, after having all the different systems and a wealth of this much of information, a lot of data requests might come up. Like we need to understand the business better and to know the functionality of each of them. So we would need different kinds of information on a daily basis. So some of these questions, how we can ask these systems are: what is the loan outstanding for customers whose household income is greater than 60,000? So to get this data, we would need customer information. So all the customer and household related information is there in the customer management system. And all the transaction details of the customers are there in the core banking system. So to answer this question, we will need data from the customer management system as well as the core banking system to talk to each other and give us the data about this. And some other questions if we specifically want to. Are the customers who are closer to the branch transacting with the branch more often? If we want to look at this. So to look at the proximity of a customer to the branch, that is there in the geographic information system GIS. Then the customer details are again there in the customer management system, and the transaction details, the loan details are there in the core banking system. So to answer this question, we would need these 3 systems to talk to each other. Then if you want to look at how does transaction volume at a branch correlate with audit scores. So the branches are audited on a regular basis, and this information is maintained in the central audit system. Then the transaction details are there in the core banking system, and the customer details are there in the system. So we would need all these 3 systems to data from all these 3 systems to answer this question. And some more questions like, what is the relationship between wealth manager's experience or training with the overall branch performance? So if you want to look at this question, so this talks about the performance of the wealth manager, the experience of the wealth manager, and training. So the experience of the wealth manager is there in the HR management system, and the training and the performance training and performance details are there in the learning management system and the CAT, which is the linked to CMS and CPS, which is required data system. So here we are almost literally talking about obtaining data from all the systems at one place, but this data, though each of these systems are not internally connected, we would need a data that is amalgamated from all these systems separately, and then such data. So now, if you want to gather data from all these systems separately, what are the challenges around you to get such integrated information? So this system actually refers to all the 6 systems that we've seen so far. These systems, many of them are located in different locations, virtually and geographically. I think the servers in which they are hosted and literally how the data is organized. So virtually they are present in different locations. So each of them have been developed by different people at different times. So some of the systems we have developed in-house, and some of the systems we have developed through external vendors who want the systems, but we have a license. Then these systems are in different databases, and actually the underlying data that is present is in very different formats. So for example, our CMS is on healthcare database, where CDF is a non database. Kind of database in which we get data in the form of text files or text files. So and then all of these data are not in one standard similar format. Some of them are in text files, some of them are in Excel files, some of them are in the database. So that is about the different formats. Each of them has been developed on different architecture. So, and they have been conceived and developed at different points in time. For example, our CDF system that we are using currently is the second version that we are using. So earlier in 2009 we had a CDF system, and during the transition from the older system to the newer one, during the transit time of 2 months, we have a dedicated system. So even in the same system, we have different data formats and a lot of different data because it's using three different systems. So each of them, if we have so many challenges in getting data, when we integrate all of them and manage all
so we saw a couple of things so far. One is that there are different systems. There is a need for these different systems. It's not that there are, because they are unorganized or something of that sort, that we are using this one. Each system has its own requirement, its own functionality. And also, parallelly, there is a need to integrate all the information from the system. Integrating the systems itself is a big challenge. So we wouldn't be well integrating the systems, but we are integrating the data from these systems because we really need to answer those questions. So some of the questions that Sowmya took us through, they really require integration from these different systems. The challenges were very well kind of presented that they are very different animals. Each of these systems is a different animal, different sizes. So really bringing them into one port is the whole challenge that we're going to be right now. So once you have this integrated, you really want it to be very smooth because you want information in one place. Right? So it should be easily accessible. So you don't want to go ask different systems with different formats that giving this information, and then integrate it all together. You want it all in one place. That's like one feature that we want in an integrated system. Second thing is it should be very flexible. So because each of these individual systems have their own architecture, the integrated system should be able to really talk to each of these systems in a very smooth fashion. So each of these systems have their own underlying formats. So some of them were built on MySQL, which is like an open source format. Some of them were built on MUMS, which is a very different kind of a format. You get Excel files, you get text files, you get SQL files, you get every format in the world, and you still need to put it all in one place. So you really need that kind of flexibility. Third real feature that we require is because it is really dealing with so many animals at the same time, it should not be slow, or it should be really able to handle very high amounts of data, and it should be really quick. Otherwise, this kind of information that you want, it will take a lot of time. Again, it doesn't help. So this system should be so robust, it should be very fast, and it should be able to handle huge amounts of data that the business really wants to handle. Very important that it should be cost effective. Like you don't want to spend huge amount of money on these systems. So really, you need to be very aware of what is the amount that you're spending on this. The other thing is that the technology that we use to integrate has to be very stable, right? It should be tested. You should be able to get people from the market to work on these systems. So suppose if you're using something very unique, which is very proprietary, it might be very difficult to get people to really develop that for you. Whereas if you're using something very popular, which is generally accepted in the market, then you will easily be able to attract talent, you will be able to attract people who will actually be able to work on your systems, develop your systems. That's like one consideration. It should not be something that is very difficult to operate on. It should not be so proprietary that no one understands that. Lastly, it should be a secure one. This is more from a data security point of view, because it's handling data from so many systems that the security of the system is very important. So, given that we wanted all these features in one system, what did we actually end up with? So, before arriving at this solution called LAMP, I will tell you what LAMP is about. We did many other things, and finally arrived at okay, that LAMP looks like a good solution, right? LAMP actually stands for Linux, Apache, MySQL, and PHP. So Linux is basically the open source operating system. So we use the Ubuntu operating system to really run these. So advantages of these are that these are very well tested and robust systems, and you don't have to pay for Ubuntu licensing. Really brings your cost down, and servers are developed by communities, and we keep upgrading them all the time, and this is true for all the code. So Apache is basically your web server. If you want to access your application through internet, you basically require an Apache server which helps you do that. So MySQL is the backend database which integrates all the other information into one place, and PHP is really a programming language which integrates everything and does the whole interaction of it. So we really used this solution LAMP. So far what we got to know is we know what kind of features that we want for the system. We know what is the right tool to arrive. But the real smart thing about this was not, we've not really taken into what is the smart thing about the system. It really had very smart workflows. So just imagine systems of this nature, different kind of 6 different types of systems working in different places, different servers, different formats. When you have to integrate them into one place, or you have to get all information into one place, where can you typically do this? Right. You basically need a time of the day where all systems are really and at only that point we will pull out information from them, because these are really huge amounts of data, and when you pull out data from this system, it really affects the front end performance of this. So just imagine at KGFS branches, people are transacting on the CMS, and at the same time, if you try to pull out the information, it will really slow down the whole performance. So the timing is so critical to do this whole integration. So typically, this integration can happen only after business hours. So typically after midnight, when the bandwidth across the country is free, no one is really using internet bandwidth, no one is working on the front end systems. That's when this guy can actually start doing his work. So the whole deal about this is it has to be so smart that it can work all night. In our office, we can't get people to work on night shifts and work on this. So you need to program your workflow in such a way that it can do all this at night. And what if something goes wrong? So no one is really monitoring this integration at night. So what it does is it really pulls out information from each system and puts it into one place. So what if something goes wrong at night? Right? So the system has to be so smart that it picks errors and really alerts or tries to have its own problem solving kind of algorithms. So there are algorithms that have been built to say that if it's not able to pick up some data from some place, it will not really stop the whole process of fail it. It will reattempt after an hour. So if the internet bandwidth is slow, or if there is some problem because of which it's not able to fetch information, we hold on, we try after 1 more hour. So if it's not able to do at 1 o'clock in the night, we start again at 2 o'clock, at 3 o'clock, at 4 o'clock. We keep reattempting, and every time it reattempts, it will also keep alerting all the system users. So the first thing that one really does in the morning is gets one email from the systems saying that I did my work at night, everything went fine, and all your systems are working fine. So that's like a confirmation that the system really gives. So it's like another co-worker who works all through the night very smartly, and it really gives all the alerts. It checks for inconsistency. It tries to rework wherever it's getting stuck. It tries to really do things once again, and finally gives you an email confirmation saying that yeah, everything is working fine. So this is really the algorithm or the USP of the smart workflows that this system is able to do. And we've really been able to customize this to our requirement. So the result of the result of all this is really the final reports, dashboards, and the analytics that we get to see. So these are some of the sample operational reports. So every day in the morning, the KGFS branches require something called a demand chart. Right? So basically, they tell people that this is the demand for the day. These are the loan collections that have to be done for the day. So this is like one kind of operational report sample. So there are like 20 other reports of this kind. And there are wealth management reports, which are basically on the basis of which advice is given to customers. This is again a product of the same integrated system that we're talking about. So there are executive reports which are like really summaries of what has happened. So each individual CEO or each person working at every level needs to see what's the performance or what are the basic things that have happened. So these are dashboards that are really available to every level. Again, a product of the same system. And the data is also used to do a lot of analytics, which is again on a different system, but the data is primarily used to do a lot of predictive analytics. So all kind of statistical things that we want to run on. The data is primarily pulled out from the same system, but there's another software that we use. So this is something that equivalent of data or XPSs, which is running open source. This system is really called R. This we not talk about the separate statistical. So we really saw so far that there were different systems, and we found ways to integrate those systems. We found ways of how very smart workflows can really help integrate them in a very smooth fashion. Manual work is really eliminated because this has to be done in the night. It has to be consistent day in and day out. So just imagine one process failing on one particular night, and the system not able to track that. Next morning it's really closed because everyone is dependent on the information the next day morning. So it has to be really so robust. But all this really didn't happen as smooth as quickly through the PPT. We learned it in different ways, some extensive ways, some really wasting time over days, but we really learned this through the tough way. Given that we were not really core technology people, but we still wanted to manage data ourselves. We were very passionate about data itself. So we learned that expensive systems not necessarily suit your needs. So given that we had these 6 different animals and it's so unique to implement. It's not necessary that the most expensive system in the world can do what we were trying to do. So we tried our luck with expensive systems, we couldn't do that. We also tried building open source systems. So we got a lot of ready-made software, so to say open source. And we spent like a couple of months trying to customize that to really get information from all these systems. We were not very successful at it, right? And so we tried everything really before we got this working. And finally, what is most important is the person who actually develops the system should really have a very good knowledge of the business. So if someone who's the world's best programmer, who knows very good programming, but doesn't really understand the KGFS and why there are 6 systems, tries to do this, do not really work. And it's so critical, so understanding of the business itself is so critical to the creation of the system is what we learn. And that's how we get such a good product. So be it your vendor, be it whether you pass it on to anyone to develop the system, taking time to make the person really understand your business is an effort that is worth investing in if you really want very good outputs or very good systems to come out. So that's really the lesson that we learned. Any questions as such?
The ability to use straight to processing. For example, the data about the customer is not in message. It will be there in both your banking as well as in your CA. Customer information. Have you used any tools for auto data set? For example, why I am asking you in a day, let us say morning some transaction happens, or some taking control, afternoon doing that. So how do you handle that situation?
So currently it is not real-time syncing the database. All
Any online service, they have a gap of 1 hour or
no, there is no syncing during the day. All the work starts after midnight. So typically after business hours, after everything is shut, there will be very bandwidth available. That's when it starts. So because trying to do this real time or during business hours really puts a lot of pressure on the front end systems. So that's why all this happens. So the reason, one disadvantage of this is that you would not get information as of last hour or last minute. The information that you have is of yesterday evening. Yesterday close of business is what is the latest information. This is really the reason because
it is sufficient for our business.
Correct.
Workflows will change.
The isolation is on PHP scripts. So that's given us a lot of flexibility to really say this is try this, that is do this, send an email, and those kind of things. So if it feels that, so it does all kinds of checks. It can really interpret if the data that has been sent is complete or not. So say if information has been cut off at a point because of internet fluctuation or whatever, it can sense that this information doesn't seem right, it seems off, it is cut off. So all those intelligences you can really build into the system. So these are all programming logics that you can connect it to a SMS gateway, it can even send you an SMS as soon as it integrates it, saying that all procedures will complete, data has been one place, it's consistent, reports have been sent out, and it's fine. You can connect it with your
CPS is handled by INP, the private institution. Are they also running the, how do you import those data? You bring it into this open source environment from that architecture to say how do you do that?
So what they do is the systems are so secure that none of the systems can connect. So what they do is the systems throw out the text files into some common space, and this guy goes and picks up those text files. So it knows that every day between 2 a.m. and 3 a.m. that there will be some data files delivered. You go pick up.
Who controls this? It's not controlled, automated, or is there any, you have some kind of a system administrator who teaches that?
System administrator is basically Sowmya.
All these are highly automated. They don't require any manual intervention.
So only you get an email from the guy saying, no, I am not doing that thing. Only then they will need to get in. Otherwise, yeah. So even before, actually what happens is, in the initial days, you should, like, Dhanai classes, for example, open at 8 a.m. From 8 a.m. we start getting calls, something has happened, it's not working. Immediately open the email and see, okay, there's something wrong that has happened, someone has forgotten to put a file or something like that. We can sort that out. But now that it's so stabilized that most processes like everything there is a result that has happened. And it's pretty automated. So every day morning you get an email confirmation and everything is fine. That's like how you start the day.
Put this like against like regarding SQL. SQL, you put that SQL you are in a position to come out with the exception reports.
Correct.
Yeah, MySQL software.
MySQL is a database. MySQL is really a database. But you can come up with any kind of
structured query language wherein you are going to effectively use that. Whatever be the correct thing, whatever is not adhering to the guideline, so you should throw your pop-up or something like that in such a way, we can treat that as an exception report from the SQL. So that for audit purpose, audit trail, I can take as an effective.
So, some of the things that are already there, for example, I can tell you that there is something called the dwell tracking report that is there. So, every branch is having a limit saying that they should not hold dwells beyond a particular amount, 6 lakh rupees or 10 lakh rupees. And the moment dwells cross that limit, it gets highlighted in red, saying that this branch has crossed 10 lakh limit. So immediately the action that is taken is the ARM arranges to move the dwell from there to another branch or to a hub. So that kind of exception is there. So you can build anything from here to that. That's one example of a lot of such exception reports can be built.
Those are not subsequent developments. So that they cannot act concurrently. Based on the previous day report, what is the action they take? So rather than taking on the spot.
Okay, so if you want knee-jerk kind of reactions, like if something happens, you want to know the immediate unit, this system can't really handle. That has to be in the original system. So if something went wrong in the audit system or in the CMS system and you want to know it real time, those kind of things have to be built in the original system. This is really post-modern, 1 day old.
I agree. My only submission is that or it is also not taking concurrently. It is only on the past record only we are taking.
Correct.
For that, if we get a state chat, that on all these, let's say, number of 3 months or 1 month as the case may be, if you could see that what are the exceptions, that with that we will be in a position to come out.
Absolutely, that is very much possible. Not possible.
What is the language being used in this?
PHP. PHP. PHP is the same language on which Facebook has been built. A lot of Facebook applications are being built on PHP. It's really flexible and it has like a web interface. Like you don't need to install a separate software or anything to access this. If you have internet, many of the users will can access.
You don't have practice of taking any printer. So you should be stored in such a way that at any point of time you should be in a position to take it, and wherever it has crossed that, you can purge and then you can get that.
Correct. That's all possible.